Alrighty guys, for the last part, we're using the same airfoil that we downloaded from the UIUC airfoil data site. So for this part, we're just going to be changing our uh, flap degree. So we're just going to be adding some flaps, 10 degrees and 20 degrees, and we're going to compare them to a plain airfoil with no flaps. So I'm going to be showing how I can change my flaps for this one here. For Xfoil, I'm gonna be again loading my Clark W dot. This is my airfoil, and I'm gonna be making some changes here. First change I'm gonna be making is adding my flap. Actually, before that, I'm gonna be changing my number of nodes and my G. So now I'm gonna be changing by typing. I'm gonna be adding flaps by typing G design. So now it says you are working with the buffer airfoil, and it's showing us the thickness of our airfoil, the camber area, all the information that we need. So I'm gonna type flap, and now it's gonna ask us to enter flap hinge X location. I'm gonna be choosing 0.7. That's my X location over here. Enter flap hinge Y location. I'm just going to type 999 to specify y over t. And for our y over t location, I'm choosing 0.5. And now it's asking us to enter the flap deflection in degrees. For this problem, uh, we were asked to add 10-degree downward deflection and another 20-degree downward deflection. So I'm adding 10-degree, and then I'm gonna hit exec. So it says current airflow nodes set from buffer airflow nodes. So for this problem right now, I'm gonna leave my GDes mode, and I'm gonna go to this operate mode. And now I'm gonna change it to a viscous flow with a Reynolds number, since we're dealing with just 1 million. So this is 1 million airfoil, my Reynolds number, viscous flow, changing my iteration to 1,000. And now we can just go ahead and look at our airfoil from -5 to 15 with an increment of 1. It's going to be taking a little bit of time, but this is my Clark W airfoil with 10 degrees of flap added to it. So I have my part of 10 degrees. This is the results that I got. I got my minimum CD drag coefficient and my max CL over CD over here. So this is my 10 degree. It's going to be on with blue. For the 20 degrees added, I can just go ahead and show it to you guys real quickly. So I'm going to my Xfoil again, I close it and open it. I'm going to be loading my Clark W dot. It's going to be showing us this, and then I'm going to be changing my number of nodes, my density ratio to 1, and I'm going to leave this mode, and I'm going to go to my GDes mode again. I'm going to hit flap, and then my hinge location is 0.7. And then my flap deflection this time going to be 20. So we can see the 20 degrees added deflection in my airfoil. So this is it. And I'm just going to hit execute. And then I'm not going to be showing you guys the process of getting, what's it called, number of airfoils and data. I mean, number of my coefficient for this 20. I already have it here. I called it 20 gig. I don't know why I did that, but this is the results that I got for a 20 degrees flap added to my airfoil from -5 to to positive 15. I can show you here the 20 degrees added to this airfoil. It's more cambered than the 10 degrees or the no flap added, so there's a difference over here. Same goes for the CD versus alpha. So I'll have them all over here, and just like a phrase explain it, that adding flaps means adding more cambered airfoil. But yeah, this is it. Thank you very much. I got all of these parts, I think. Yeah, so 3 parts. Each part has 3 plots, comparing CL over CD versus alpha, CL versus alpha, and CD versus alpha. All the results, I put them in these tables with plots. With every graph, each graph has explains a specific airfoil with a specific Reynolds number or an added flap to it. And yeah, this is it. I'm gonna stop sharing. Thank you very much. My name is Ismail Kamal Simlali again. And yeah, that's it. Thank you.